Participants understanding the problem related to supply of water, access to sanitation facilities, and having an adequate sewage system is crucial as large and rapid increase in urban population is throwing up new and unavoidable challenges. Currently, around 55% of the global population lives in urban areas. This number is expected to grow to 68%, implying that around 6.4 billion people out of 9.8 billion people will be living in urbanized space by 2050. India has 6 megacities with population over 10 million and another 47 cities with a million plus population. Since 1990s, most of Indian cities have grown exceptionally large and now accommodate a big chunk of neo-urban population. However, in most cases, cities could not keep pace with the rate of population growth, hence they lack adequate infrastructure and services such as paved roads, adequate water supply and sanitation facilities. Overall, there are over 4,000 towns in India and many do not have adequate municipal infrastructure for growing needs. With 459 million people in urban areas, India is one of the fastest urbanizing nations. India obviously faces several issues in urban water supply and sanitation infrastructure and their management. Across the world, the local municipal bodies or local urban bodies manage the supply and collection of wastewater. Hence, in this lecture, both topics will be covered. Urban water management comprises the planning, designing, maintenance and operation of urban infrastructure for meeting the standard service requirements for drinking water and sanitation. Besides, various civil engineering structures are also put in place for controlling the stormwater runoff, for promoting infiltration and rainwater harvesting, and to meet the need of urban ecosystem and recreation. Hence, urban water management is an integral part of urban planning. Unplanned and unforeseen vertical and horizontal growth of cities adds several stresses to these services. Now, let's talk about municipal water supply system. Municipal water supply system is a public water supply system to supply fresh water for human consumption through a setup of pumps and pipes. According to the Environmental Protection Agency of United States, this year-round water supply system should have at least 15 connections in service or regularly to at least 25 individuals. This system can be either state or private owned or normally charges for water supply. Before supplying municipal water is processed and treated to meet the drinking water quality criteria. A community's water consumption is characterized by numerous requirements including domestic demands or public need, commercial and industrial uses. There is usually a wide disparity in total water requirement of different communities. Water requirement for drinking, cooking, washing, laundry and other household functions come under domestic demands. Water used for street cleaning, used in schools and other public buildings and for fire safety comes under public needs. Commercial and industrial demands include water for hotels, restaurants, laundries, stores, offices and most manufacturing plants. This demand depends on population, geographic location, climate and extent of local and commercial industrial activities and the cost of water. These municipal bodies require huge quantity of water on daily basis. Let's see where from these institutions bring the water. Water supply system receive water from various locations after appropriate treatment including groundwater, surface water and sea through desalination. Both groundwater and surface water is essential for fulfilling the water supply needs of the communities. Reservoirs and lakes are the usual source for water to the large cities, whereas groundwater is a common source for single home and small towns. Generally, raw water is collected from groundwater sources or from a surface water source within a watershed. However, in most cases, the water demand of mega and large cities are much higher and usually met by inter-basin transfer of water. Let's learn it more by an example. With over 20 million population, Delhi requires 1260 million gallon of water per day. However, Delhi Jal Board is able to supply only 937 million gallons water per day. The Yamuna, Ganga, Ravi and Bias rivers account for 91% of water supply to Delhi. The remaining requirements are fulfilled by groundwater abstraction. If we talk about Mumbai, with over 20 million residents, Mumbai requires over 1100 million gallons of water per day. However, the Sewage body BMC supplies 990 million gallon water per day. At present, 7 lakes or reservoirs located in Mumbai, Thane, Palghar supply drinking water to Mumbai city. The water is transported to the city from the sources located within a city or a distance for over 100 km. The water procured by the municipal body cannot be supplied directly. Depending on the source of raw water, water may be contain varying amount of trash, suspended materials and dissolved constituents. The raw water obtained from groundwater or surface water sources require treatment to meet the established minimum water quality criteria. Hence, require a treatment. In general, water treatment steps include purification, disinfection through chlorination and sometimes addition of fluoride. A variety of physical and chemical processes are used to treat the raw water. The conventional water treatment process of surface water consists of screening and straining, chemical addition for coagulation and flocculation, sedimentation and clarification, filtration and disinfection. Screening and straining is a physical process to trap debris. Large metal screens are placed in front of surface water intake to trap large items while water passes through it. These screens require routine cleaning. This process not only helps in having a sense of clean water but also reduces the chance of debris getting stuck into the impeller of water pumps. Once water is received into the treatment plant, coagulant chemicals are added to clump the floating suspended particles. Some popular coagulants are used in this process. Rapid mixing units or flocculations are used for quick and thorough mixing. Subsequently, the speed of water mixing is stabilized to facilitate formation and growth of floc and settlement in clarifiers. This process also helps in removing the majority of suspended material prior to filtration. It is a crucial step to avoid overloading or choking the filters. Hence, facilitates more water to be filtered before the filters are washed. In the process of filtration, clarified water is allowed to drain through the layers of sand and gravels. At this stage, the water looks clean and clear. However, this water might have presence of biological contaminants such as bacteria and viruses. Therefore, chlorination process is employed as a common disinfection step. In this step, either chlorine gas, chlorine dioxide or hypochlorite bleach is added in known amount to ensure all microorganisms are destroyed. Excess addition of chlorine may cause odor and taste problem to the consumers. Groundwater does not often require clarification, but it should be disinfected as a precautionary measure to protect the public health. Additionally, the process of softening, aeration and fluoridation may be used based on the quality of raw water. Some water treatment plants utilize water from more than one source. Blending groundwater with surface water is a common practice to improve the quality of water. In the coastal areas with limited availability of fresh water resources, desalination process are used. Now let's try to understand this process by giving example of Delhi Jal Board. Delhi Jal Board is equipped to treat 790 million gallon water per day, inclusive of about 100 million gallon of groundwater. The four-step process starts after raw water enters a water treatment plant before releasing to public. Through pre-chlorination, impurities are removed using screens, alum and polyaluminum chloride is mixed into water to remove mud and dirt. In the second step, both chemicals together act as a coagulant, clumping and allowing to settle suspended particles in the water, which are removed in clarification or as a sludge. This clear water is then allowed to pass through sand and gravel filters. In the fourth and final step, chlorination is done to kill pathogens during storage and transport. The water samples collected before and after treatment are analyzed for 25 physico-chemical and biological parameters by the Delhi Jal Board. After the treatment steps, water is ready for supply and is stored either in underground tanks for direct pumping or is pumped to overhead storage tanks before supply. The stored water is pushed through a complex network of mostly underground pipelines consisting of transmission lines, distribution lines and service pipes all over the city. This distribution system consists of large water pumps at treatment plant, overhead and underground water storage tanks, large and smaller pipelines, shut-off valves and water meters in houses or buildings, and taps at household level. These systems are designed to maintain sufficient pressure for the operation of plumbing fixtures and fire hydrants and to deliver adequate quantity of water to the end users. Too much pressure may result in leaks and breaks in the pipelines. In the case of Delhi Jal Board, treated water is supplied to a large primary underground reservoirs for storage. From these underground reservoirs, water is supplied 24/7 to different parts of the cities using water pipeline networks stretching over 13,000 kilometers. From a primary underground reservoir, water is either supplied directly to colonies following fixed schedule or is sent to a secondary underground reservoir to cater the group of colonies.